Good evening. This is VK3EKH, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast, coming to you from the studios of VK3CSJ in Narre Warren South. Very pleasant good evening to you on this last day of September, 30th of September, and we start a new month tomorrow. And don't forget to say rabbits at midnight for good luck if you do that sort of thing. We're broadcasting on prime frequency of 3541 kilohertz in the 80 meter AM band, and simulcasting on 160 meters on 1865 AM, and also broadcasting through the Melbourne television repeater VK3 RTV Digital Channel 1 HD, and also via my YouTube channel VK3CSJ, which you can find in the YouTube search engine, and also via the ASV website. I hope all the audio levels are right now. Everything's moving as they should, so it looks like we're all there tonight. We have an email address if people wish to send signal reports tonight, vk3ekh@gmail.com, vk3ekh@gmail.com, and we also have a chat window, a Discord chat window, which is available through the ASV website via the Radio Astronomy tab. Very pleasant good evening to everybody, and you can almost feel the summery feel in the air coming on. This Sunday is daylight saving, so we move our clocks forward, and on Sunday, so we'll be having a little bit of extra daylight in the evening hours, which will be nice. The Astronomical Society of Victoria was founded in 1922. It comprises over 1,600 members throughout Victoria and other states of Australia and overseas. Membership of the Society is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy, to disseminate the knowledge of the science, and to provide greater facilities for this study among its members. Monthly meetings are usually held on the second Wednesday of each month, except in January, with the latter being held on a Saturday night. Meetings start at 8 p.m. at the Mulia Hall, Burwood Avenue, Melbourne, near the Melbourne Observatory, which is located not too far from the Shrine of Remembrance. Parking is available in Burwood Avenue, Dallas Brooks Drive, and within the surrounding streets. Admission is free and visitors are most welcome. Privileges of membership include the right to borrow books, periodicals and other publications from the library, the Society's extensive library, located at the Melbourne Observatory. Receipt of the ASV newsletter, or ASV magazine as it's now called, which is called Crux, containing articles, news, observing notes and the like, and the free provision of the Astronomical yearbook. Access is available to telescopes on members' nights held regularly at Melbourne Observatory and after monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's also a 200mm refractor managed by the Royal Botanic Gardens, and a photoheliograph which are housed at the observatory are also accessible to members as well. The Society also has a number of 200mm reflectors available for short period loan, so members can try before they buy concept. Members are encouraged to make use of the Society's, just finding my other pair of glasses here. No, it's not them. Yeah, hang on a sec. Just put on my proper reading glasses. That's a bit better. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90 minutes drive north of Melbourne. There are a range of instruments available for members to use, the two larger ones with appropriate training, which range from 300mm to 1000mm in aperture. Also located on the site is the 8.5 fully steerable radio telescope, which members can access with involvement with the radio astronomy section. And a very pleasant good evening to Phil and anybody else that's listening tonight from the RAS section. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the number of common interest activities catered for within the society. Other areas of interest that the members can participate in include deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet, radio astronomy, computing, cosmology and astrophysics, historical studies, research, and astronomy in general. Contact details for various section directors are provided in the yearbook, but if you don't have access to the yearbook, then the website is the next best thing. Further information may be obtained by visiting the ASV website at www.asv.org.au, and notifications of events are given in the Crux Extra Bulletins, which is an extra publication that comes out via email to members only every other week, just to keep members abreast of what's happening. Please note that ASV will conform to all government health directives, and ASV events may be required to be cancelled, moved or postponed. Information can be gleaned if you write to the Secretary of the Astronomical Society of Victoria at GPO Box 1059 Melbourne, Victoria 3001. That's the Secretary, the Astronomical Society of Victoria, GPO Box 1059 Melbourne, Victoria 3001. And or visit the website at www.asv.org.au. Sorry. No, that's right, yeah. www.asv.org.au. That's right. Now, all right, we have a few things tonight. There's a couple of videos that I'd like to try and squeeze in. So, being at the beginning of a new month, we have the Sky Notes from Planetarium. So we shall go into the Planetarium notes, Sky Notes, and see what's up in the sky. Very pleasant good evening to Don, who's emailed me there. Great signals again, as he reports. Excellent stuff. We have Mitch, VK3ZT, and Rich, VK3VRS, on the chat window. So come and join us on the chat window. Alrighty then. Towards the end of the month, I should mention too that the ASV is hosting an Astro Fest of some sort up at Sea Lake. It's called Sea Lake Astro Fest 2022. It's basically in conjunction with the fact that we're celebrating our anniversary, 100 years. And this should be, hopefully the weather will be nice. It's slated for the 29th of October to the 31st of October. I think tickets are pretty much sold out from what I gather. But more information about the Sea Lake Astro Fest 2022 up at Lake Tyrrell. It can be found from the homepage of the ASV. Sky Notes. Now, interestingly enough, as far as the planetarium goes, you've got what's called Planetarium Nights, after hours, adults only sessions, astronomy and art house full dome film that change monthly. Also, there's what they call, I won't worry about that. Now, the other thing, on Tuesday, the 8th of November, I mean, this is a little bit ways off, but on Tuesday, the 8th of November, at the on Zoom, they're having the planetarium is having a Zoom type get together. It's called Astro Hour, Guide to the Lunar Eclipse, an expert guide to understanding the viewing of upcoming total lunar eclipse, an online event for families coming up in November. Let me just see if we can get some more information on that. An expert guide to understanding and viewing of upcoming total lunar eclipse. Join Science Works online for Astro Hour, explorations of astronomy and space science, and with astronomer Dr. Tanya Hall. And I've got a picky of Tanya. Here she is. Good old Tanya. And I've had a chance to meet this young lady. Stress not old. Anyway, so get a chance to catch up with Dr. Tanya Hall and educator science nerd Douglas Bair. I think that's how you pronounce his surname. That's this guy here. It's Douglas Bair, B-A-I-R, Bair, whatever. But anyway, you've got those two guys doing a bit of a presentation on Zoom about the lunar eclipse. And they say here that on Tuesday, the 8th of November, will be treated to a special astronomical event. The moon will rise over the horizon and then move into the Earth's shadow, a lunar eclipse. In this edition, we'll share all you need to know to see the upcoming lunar eclipse from Melbourne and across Australia. But how does an eclipse happen? Tanya and Doug will show you exactly what's going on in the sky when we see a lunar eclipse. We'll also explore the difference between a lunar eclipse and a solar eclipse and why our moon looks so huge as it hangs low in the sky. With your newfound eclipse knowledge, you'll know exactly what is happening when you step outside after the session to view the moon as it rises above the horizon and moves into the shadow of the Earth. So the session will include interactive elements and Q&A and is aimed for family audiences and is best for children plus 10 or 10 plus. And Dr. Tanya Hall is the Melbourne's planetarium astronomer. She loves exploring the universe and it never fails to amaze her. It was the Orion Nebula that led her to exploring all the wonders of space, and she reached for the stars ever since. And as far as Mr. Blair is concerned, Mr. Bair, what are they saying about it? Oh yeah, Doug's enthusiasm for science and passion for performing has led to many and varied science communication adventures over the last 15 years, including working with astronomers, penguins, and most importantly, inquisitive minds. So, amazing grace. All right, so let's get back to the sky notes. Okay, so that's coming up on the 8th of November, but I'll remind you chaps before all that day occurs. Welcome to October Sky Notes for a month worth of data, dates and night sky information. We revisit some fascinating topics covered this time last year, adding extra links and content, but first, this latest news from James Webb Space Telescope, some 1.5 million kilometres out into space. And they're actually making reference to the rings around Neptune, which I featured last week. Jupiter was astonishing in images in August, and now here is Neptune, appearing as a shimmering orb in the darkness of space with an ethereal halo amid hovering spirits. This is a near-infrared camera image. I haven't got that actually on the screen, but you can. I showed it last week anyway. But it shows what the James Webb Telescope managed to photograph of Neptune and its rings and a few moons, which I showed last week. Sky Notes also has a little bit of a breakdown on DART, the space ship or probe that impacted on a small asteroid, Dimorphos, and I've got a little bit of a video on that, so I won't harp on that for too long. I'll let the video do all that, so I'm going to jump straight to Melbourne sunrise times. Okay, from tomorrow, the 1st of October, the sun will rise at 5:56, setting at 6:24. On Tuesday the 11th, the sun will rise at 6:41, setting at 7:33. So you can see straight away things have changed. On Friday the 21st of October, The sun rises at 6:27 and sets at 7:42. And then on Monday, at the end of the month, Monday the 30th, sunrise at 6:14, setting at 7:53. And the day length at the beginning of the month is 12 hours and 27 minutes. And then by the end of the month, it's 13 hours and 38 minutes, getting a little bit longer every day. Moon phases. On the 3rd of October, Monday, there's a first quarter. On the 10th of Monday, the 10th of October, it's a full moon. On Tuesday the 18th, it's a third quarter. And then on the 25th of October, Tuesday again, it's back to a new moon, or to a new moon. And on Monday the 17th is lunar apogee, which is furthest from the Earth at 404,328 kilometres. Then towards the end of the month, at the 30th, it is at lunar perigee, nearest to the Earth, at 368 kilometres. That is 368,000 kilometres, 290. I'll start that right up. 368,290 kilometres. How's that? That's a better figure to read. You're tuned to ASV Radio, VK3EKH. Planets. Mercury is approaching its passage around the Sun and will not be visible this month. It will return to our evening skies in December as at dusk in the southwest. Venus is also about to disappear behind the Sun, but will be back in the evening in our western skies early in January. Mars is getting closer to opposition opposite the Sun as seen from Earth. It is a morning planet, visible on the northeast from 1 a.m. and will then be lost in the early morning light shortly after 6 a.m. Jupiter too is nearing opposition. It can be seen brightly in the eastern sky from 8 p.m. and will move during the night across the north and drop below the western horizon shortly after 5 a.m. Saturn is visible from 10 p.m. in the northeast, and it too will transverse the north until by 3 a.m. where it will be lost low down in the west. Meteors. The Ionids are visible from the 15th to the 29th, but peak on the 21st and 22nd of the month, with estimates of around 30 meteors per hour. The best time will be from around midnight until early dawn. The shower is centered on Orion the Hunter near the red supergiant star Betelgeuse. These meteors are typically very fast and bright. They enter the atmosphere at about 66 kilometers per second and vaporize 100 kilometers above the surface, leaving persistent trails in the sky. The conversation has a detailed guide by Dr. Tanya Hall and Professor Joni Horner. The conversation is a website, which you can find by, I guess, just typing in the conversation. But anyway, they go on to say that humans have observed and marvelled at meteor showers and comets throughout recorded history, but the connection between specific meteor showers and comets is a recent understanding. For some ancient cultures, they were omens or messengers. The Ionids shower was first recorded by Chinese in the year 288 AD and is associated with Comet Halley. The famous comet is named after astronomer Royal Edmund Halley in 1705 after studying earlier records of certain comets that seemed to reoccur and applying Newton's new laws of motion. Halley calculated its elliptical orbit around the Sun successfully and predicted its return in 1758, which sadly he did not live to see. Comet Halley orbits the Sun every 75 years on a path that takes it out beyond Neptune. Each time it passes through the inner solar system, it leaves in its wake a trail of particles for our planet to pass through. Twice a year, Earth intersects the comet's previous orbits and we enjoy the meteor showers. The Eta Aquarids in April-May and the Ionids in October. In 1986, during its last visit to the inner solar system, Comet Halley was observed from telescopes and a flotilla of space probes. Okay. And of course you've got the Taurids as well. Another meteor shower that could be enjoyed late this month, although less impressive than the Oranids, is the Taurids, linked to Comet Inc. E-N-C-K-E Inc. This is a long duration shower in spring that actually peaks in the first week of November. There are two branches, one near the star cluster Pleiades and the other close to the red star Aldebaran in Taurus, each giving 10 meteors per hour that can be bright and slow with colourful fireballs. Alright, stars and constellations. In the north, as the year progresses, we see Aquila, the eagle, and its principal star Altar directly north, but Lyra and its bright star Vega have left our northern skies this month. In the west, Scorpius is now moving down to the west with a red giant star Antares, the middle of the three stars that make the Scorpion's body. High above, following the Scorpion, is the asteroid the Teapot, which gives you the position of the bow and arrow held by the Centaur Sagittarius. Looking towards the east, you've got Fomalhaut in Pisces. The southern fish is the bright evening star in the east this month, but as spring ends and we move towards summer, we will progressively begin to see from the northeast around the southeast, from the northeast around to the southeast, the beautiful Pleiades cluster. Taurus the bull and Aldebaran, Orion the hunter with the saucepan, and Betelgeuse and Canis Major and Sirius. See our stellarium screenshots for the Oranids meteors looking east from 1 a.m. So if you've got Stellarium is free software that you can download, which is absolutely a fantastic program for being able to see what's up in the sky, and you can scan back into the past history and then go forward into the future to see what astronomical events are occurring apart from what's up at the sky right now. Anyway, all right, let's get on to the next thing. Okay, in the south, if away from bright lights, you can see in the southeast the isolated large and small clouds of Magellan, our galaxy's nearest neighbours, as well as the vast bands of billions of stars and dark dust clouds that make up what we see of our own galaxy, the Milky Way. In the evenings this month, it runs into a broad arc from south to north. From our location, about 28,000 light years from the centre of our disc-shaped galaxy, we have an edge-on view along the plane of the galaxy where the density of stars is at its greatest. As you look away from the Milky Way to either side of the sky, you see far fewer stars. In those directions, you are peering through only 1,000 or so light years out into the intergalactic space, to the north or south of the galactic plane. Being inside something in the dark doesn't help much in trying to work out its size or shape. It says here, where we are in the galaxy, and its size and shape was not fully understood until quite recently. Low in the southwest are the pointers Alpha and Beta Centauri in the constellation of Centaurus. Following the line of the two bright pointers, lower in the horizon leads to a small but famous Crux Southern Cross. Crux and the pointers are among many southern hemisphere stars that are referred to as circumpolar. From our southern latitude, they trace a curve. They trace curving paths through the night sky and are always above the horizon. So these circumpolar objects never go below the horizon. Circumpolar means around the pole. As our planet rotates, some stars rise in the east and set in the west during the night. That's diurnal motion. Diurnal motion, the daily returning of the Earth. It is the same reason why the moon, the planets and the sun all appear to rise in the east and set in the west. But stars that are far enough south or far enough north in the northern hemisphere take half-circle paths during the night, remaining above the local horizon at all times. They never set and complete their circular journey during the daytime when they can't be seen. However, there are two extremes of this around the pole motion. At the South Pole, months-long winter, no stars rise or set, all remain above the horizon, all are circumpolar. But at the equator, stars are all seen to rise and set during the night, none are circumpolar. A fixed camera set for a long exposure can record trails of stars, making curving paths across the sky during the night. Such paths are centered around the south celestial pole, the point around which the stars appears to turn as the Earth rotates. The south celestial pole represents the position in the southern sky our planet's axis of rotation points to. At the South Pole, which is latitude 90 degrees south, it would be above at the zenith, the point above your head. But from Melbourne's latitude of 38 degrees south, the SCP sits 38 degrees above the southern horizon, which is 52 degrees away from zenith. And there's a picture of it, and I didn't save that, sorry. All right. Now, just a few times for the International Space Station here. At a distance of about 400 kilometres above the Earth, the International Space Station completes an orbit every 90 minutes. And it appears as a bright point slowly moving across the night sky. On Monday the 10th, there's a passing at 5:54 a.m. to 6 o'clock a.m. Coming in from the southwest to the northeast. Then on Thursday the 13th, there's a passing at 5:05 a.m. to 5:10, coming in from the southwest to the northeast. Then on the evening of Friday the 14th, there's a passing starting at 8:54 p.m. to 8:58 p.m. northwest to east. And then on Monday the 5th of October, okay, I'm not sure about that date now because it's, I don't know about that date. But anyway, they say here Monday the 5th of October, there's a passing at 8:03 p.m. to 8:10 p.m. northwest to the southeast. I don't know why that date isn't first, actually, so I'm not sure about that date. But all information about passings, the any satellite, any planetary object in the sky, all that information can be found from the Heavens Above website. All right, it's coming up to 10:30 already. This is VK3 Echo Kilo Hotel. I'll just read a few dates out, not many. On the 3rd of October 1942, first object to reach space, the experimental V2 rocket was launched from Peenemünde, Germany, in a brief flight over the Baltic. 1942. On the 4th of October 1957, Sputnik was launched to become the first artificial satellite. Also on the 4th of October 2004, Spaceship One was launched as the first private telescope into space. Private spacecraft, not a telescope, private spacecraft. And on the 5th of October 1923, Edwin Hubble established that M31, the Andromeda Galaxy, is separate to our own Milky Way galaxy. And on the 7th of October 1959, first photos of the moon's far side are taken by Lunar 3. And last date, on the 9th of October, 1604, a Type 1a supernova 20,000 light years away in the constellation of Orpheus is visible from Earth. And on the 17th, Johannes Kepler observes and publishes his account of the new star. It is the most recent supernova visible to the naked eye in our galaxy, and we're overdue for another one. There's plenty more dates, but I'll leave that till next week. You're tuned to ASV Radio VK3EKH, coming to you from the studios of Narre Warren South. A very pleasant good evening to Don, Andrew, and Steve, who've sent me emails and reports. Thanks, guys, for those reports. We've got just a quick look at the chat window. We have Brett, VK2CBD. G'day, Brett. Joe, VK3BKI, have joined in, and they're all having a deep and meaningful conversation. Okay, now this next half hour is just going to go. Martin Schmidt, I think that's how you pronounce his name, the father of quasars, dies at the age of 92. Famed astronomer Martin Schmidt's 1963 breakthrough discovery rocked the astronomy world, helping to change the universe's origin story. We have a picture of Martin here, which I shall just bring up. There he is. There's the old bloke. And the story goes, and it's not very long. What you're seeing there is Martin Schmidt seen here investigating a spectra in 1965. Played a pivotal role in the unravelling the early mysteries of quasars. The world of astronomy mourned the recent passing of Dutch-American astronomer Martin Schmidt, the first person to measure the distance to a quasar. This groundbreaking work in the 1960s greatly expanded the size of the known universe, providing one of the first clues that the Big Bang Theory was correct. Schmidt died on the 17th of September at his home in Fresno, California. He was 92 years old. The story of quasars began several years before Schmidt focused his attention on them. Starting in the 1950s, astronomers identified several sources of radio emissions in the sky. Many of those radio sources could be assigned to known objects like bright stars or nearby galaxies, but some remained frustratingly elusive, having no visible counterpart. Whatever these strange radio sources were, they appeared as point-like objects, indicating that they were either huge in size, but incredibly far away, or small and nearby. Astronomers never slow to assign a name to a new category of celestial phenomenon. Quickly designated these radio sources called quasi-stellar objects, which was shortened to quasars. Schmidt, who received his Doctor of Philosophy from Leiden University in 1956, under the tutelage of Dutch astronomer Jan Oort, or the Oort cloud fame, of the Oort cloud fame, eventually moved to California Institute of Technology to continue his studies into the properties of evolution of galaxies. Among Schmidt's many accomplishments during his tenure there, he was the first to discover that the density of interstellar gas within galaxies was proportional to their rate of star formation, a relationship now known as the Schmidt law, of course, or more recently the Kennicut-Schmidt law. Schmidt then turned his attention to finding the light spectra of radio sources, especially these mysterious quasars. By the early 1960s, astronomers had been able to identify optical light counterparts to one other quasar, but its spectrum remained poorly understood. Its light output did not match any other known type of astronomical object. In 1963, Schmidt used the 200-inch Hale telescope at Palomar Observatory to discover the optical counterpart of the quasar known as 3C273, one of the first to be discovered. He also gathered the spectrum of this poorly understood object, and that spectrum featured strange emission lines that once again defied explanation. After several weeks of deep contemplation and much nervous pacing around his home, Schmidt realized that he was looking at a perfectly normal galaxy. All the emission lines from all the usual elements were there, like hydrogen and helium, but they were simply shifted far down toward the red end of the spectrum. The light spectrum of an astronomical object can shift from two things. One is the Doppler effect. If an object is moving away from us, the wavelength of its emitted light will lengthen, and its emission lines will be red-shifted. But the position of emission lines from 3C273 implied a recession velocity of around 100 million miles an hour, some 15% the speed of light. This redshift result was orders of magnitude larger than that found for any other known object. Schmidt argued for another interpretation in his Nature paper describing his discovery, the Big Bang. Distant objects are pulled away from us due to the explanation of space itself, which also causes a redshift. It was this realization that allowed Edward Hubble to lay the observational groundwork for the Big Bang theory in the 1920s. But besides Hubble's insight, there was little more to anchor the Big Bang in observations, and so astronomers continued to debate its validity. That word. Schmidt's work showed that 3C273 was billions of light years away, making it the most distant astronomical object known at the time. This discovery of the first distance to a quasar dramatically rewrote our understanding of the true scale of the cosmos. Hasn't that been tested a few times now? For quasars to be detectable at such vast distances, they must be insanely luminous. In fact, they must be the most luminous objects in the universe. Schmidt believed that when we observe a quasar, we are seeing the light emitted as gas violently swirls and grinds together around a gigantic black hole in a newly forming galaxy, which turned out to be the correct interpretation. The existence of quasars provide proponents of the Big Bang theory a major observational win. Quasars only appear in the distant universe. There are no nearby objects like them. In the Big Bang model, the universe changes and evolves as it continues to cool and expand. And because quasars are only found far, far away, they must have only existed in the early universe, not our modern day one. In 1966, the Time magazine put Schmidt on their cover, likening his discovery of the true nature of quasars to those of Galileo's in its power to reshape our understanding of the universe, and an accomplishment like that is sure to live on. So you're tuned to ASV Radio, VK3 Echo Kilo Hotel, coming to you from the studios of VK3 CSJ. All right. Next we have a little video. Let me see if I can just get this quickly running. Now this is about our DART probe, and what I'll do is just cue that up, and that's ready to go. So this only goes for about 8 minutes. NASA, as we all know by now, NASA crashed a spacecraft into an asteroid, and the double asteroid redirection test, that's what it's called, DART, double asteroid redirection test, successfully showed that it is possible to crash a spacecraft into a small asteroid. Whether the approach could save Earth from a future threat remains to be seen. All right, I'll just run this video, and let's see if we can just get back to vMix. Okay. All right, stand by for this. You'll have to watch YouTube. There's sound, of course, but it's advisable to watch my YouTube channel for this one. Just the nature of things.
Hello, it's Scott Manley here. Last Thanksgiving, I was standing on the side of a road with my family watching this spectacle, a Falcon 9 lifting off from Vandenberg, carrying the DART mission into deep space. Yesterday, I was at a fine little party in San Francisco with the B612 Foundation, watching live feed from the DART spacecraft as it headed towards its target. Now, this is sped up a lot, but on the bottom left, that is the asteroid Didymos. That is not the target. The real target is its moon, which has officially been named Dimorphos, but the cool people still call it Didymoon. It was expected to impact at a speed of about 6.1 kilometers per second, completely destroying the spacecraft, which is an unusual way of declaring mission success. These images came down from the Draco camera system essentially live. We got 1 frame per second as the vehicle closed in. And these are close-up images of the smallest asteroid we've ever got close to. And that was the final moment. We got a partial image down before the spacecraft stopped transmitting, presumably because it was now, shattered into atoms. So yeah, the last full image we got, that is about 100 meters across. So those boulders are several meters across. That's 100 feet by 100 feet, 10 feet size boulders on the surface of this rock. Thanks to the power of video editing, I decided to actually take the last few frames and just smooth them, essentially scale them so that we transition from one frame to the next. And yeah, so this is very obviously a rubble pile asteroid. It is oblate, which means it's stretched out in one axis. Notice on the bottom left, there is something which sticks out beyond the dark side and is catching the light. But also notice that the stretching, the oblateness, is in the same axis as its orbit, which you would expect because that's probably induced by a tide. I expect that this is tidally locked to its parent body and that's stretched out in that shape because of the gravity gradient. Another thing to notice is there's no craters on this body. Craters on planetary bodies tend to form they need gravity to form. There's not really enough gravity. The debris gets kicked out and it lands back all over the asteroid. And as DART closes in to make its own impact event, you can see that it's actually pretty much heading for that big boulder right in the middle. Obviously, they couldn't pick that out from a distance. They had to take what they could get. This is, it'll really be interesting to see if we can pick that out when a mission goes to it in a few years' time. So this is a slightly cleaner version of the final image released by NASA. They just basically scaled the image, fixed the curves to actually bring out more detail. This is basically the best image we've got here. And what jumps out to me is there's a lot less fine gravel than we've seen on other rubble pile asteroids. And I guess the best comparison is Ryugu because it's much larger and it's very clear that the surface of Ryugu in this image has a lot of fine material. Whereas I think that when you've got, the lower your gravity goes, the more you're going to lose the very light, fine material because when you hit a bunch of stuff, the lighter stuff kicks off at a higher velocity and is more likely to be lost. So anyway, hours after the images started to come down from telescopes all over the world, watching the expanding cloud of dust and debris that had been kicked up by this. Remember, this is a science experiment, and if the difference between science and messing around by blowing up asteroids is writing it down. So this image sequence is from the Atlas project. That's the Asteroid Terrestrial Impact Last Alert System. And that's a series of telescopes around the world which are looking for small, fast-moving asteroids near the Earth. This particular telescope was in South Africa. They have telescopes in Hawaii, but Hawaii, it was daytime, so they couldn't make observations. Anyway, what you're seeing is the asteroid being tracked by the telescope is fixed in the middle. The stars in the background are moving by. Those are nothing to do with it. But the object, it's brighter afterwards than it is before because there's probably a cloud of debris nearby. The cloud that expands off, you'll notice expands in one direction because the impact happened on the side. And it forms a shell because the event is short. So the stuff gets thrown off at high speed and then the source of the stuff gets cut off. So you form this sort of wave that goes away and then it dissipates. And this is seen by other observers. This is from the South African Astronomical Observatory, I believe. Again, in this case, they're letting the asteroid move through the field of view, but you still see the increase in brightness and the formation of this cloud headed in front of the asteroid's apparent motion. And again, it's important to remember that the object that we are seeing in these these images of the asteroid is mainly the parent body. The moon is much, much smaller and only contributes a very small amount to the brightness, but both of those are outshone by the brightness of this big cloud. And that huge cloud is key to what the DART mission is about. DART is supposed to demonstrate the ability to divert an asteroid. And that stuff blowing off is almost like a rocket plume. It enhances the momentum transfer from that parent spacecraft. And when modeling these kinetic impactors, you have a factor called beta, which says if you have a beta of 2, you multiply the momentum transfer by 2. So it gets you better momentum transfer. Now, there's a lot of questions as to what this might be. It's a very complex process, and there's a lot of unknowns. This is the best way for us to actually get an idea on what it might be. At the B612 event, the founders, Ed Lieu and Rusty Schweikert, declared a public wager as to what they believed the numbers would be, betting a dinner. Ed thought the numbers would be higher, Rusty thought they would be lower. I'm really fascinated to find out what they will be. But it will actually take several weeks to actually get enough orbits in, because how we're going to measure the effectiveness is by how much the period of the orbit changes. We've got a 12-hour orbit that we need to slowly watch the orbit come out of phase with its previous motion, and then we'll know just how much the velocity of the asteroid changed. And over the next few days and weeks, we can also expect more results from telescopes. We have this James Webb Space Telescope was watching, and we do have these raw images right now. I expect that we will get these cleaned up and we will get more detail on that debris cloud. Now, as for the view from the impact site, obviously we couldn't get anything from the parent spacecraft because it crashed into the asteroid and stopped transmitting, but it did carry along a little sidekick called Lichia Cube that was going to do some drive-by shooting off the impact, and the images just got released about 20 minutes ago. And I fully expect more science to be done with these images. But on the bottom, on the left, that's the main asteroid. On the top right, that's the moon. And you see very quickly the moon, as it's hit, outshined its parent body. And then the debris cloud starts to expand. And what I'm seeing here is this is not a simple linear expansion, right? So these lines are not straight. There's dynamics inside, that ejector process here. And I think that just basically shows that this is not a simple body, right? This isn't a spherical cow, as we say. Right? When this probe hit the surface and just piled into the object and released all this energy, you're going to get jets of material coming out. And as the material redistributes because of that energy, those jets are going to change direction. And that's my theory as to why we see these structures here. I really want to see more and find out more. Of course, the Hera mission will go and see the aftermath as well. So congratulations to the team behind DART. Thanks for proving that we can, in fact, save the world from killer asteroids. I'm Scott Manley. Fly safe.
And yes, Scott's given me permission to show his little videos that he does with his little accent that he's got there. I always find it interesting. All right, and this damn linear amplifier that I've got's mucking me around on 160. All right, now let's see. I've just got enough time to run the Tanya Scoves solar report. Now, the solar report is pretty much for last week, because she issued this report on Sunday or Monday last week. So again, when it comes to the ASV broadcast, it's always a little out of date. But at least the report will be interesting from a point of view of how the last week has turned out from the latest with our sun's activities. So let's just go with Tanya. And this one here doesn't go for very long. I think this is 8 minutes too, actually. This is VK3EKH ASV Radio, coming to you from the studios of VK3CSJ.
We have multiple big flare players on the Earth-facing disk, which means radio blackouts are on the menu. And along with some fast solar wind, it looks like we might have an Earth-directed, stealthy solar storm. Those stories and more in the news this week. This space weather forecast is sponsored in part by Millersville University. Come get certified in broadcast space weather. Visit millersville.edu/SWEN. Space weather this week gets more interesting by the minute. As we take a look at our Earth-facing disk, you can see a big coronal hole that's rotating in through the Earth strike zone right now. It's sending us some fast solar wind, which could bring a little bit of aurora to high latitudes, especially over the next 24 hours. Maybe a slight possibility of some aurora down at mid-latitudes, but it won't last all that long. Meanwhile, we also have a big coronal hole in the south, and that will be rotating into the Earth strike zone in about a week. But take a look in between the two. Do you see that bright region beginning to emerge right around center disk? Well, this region early on the 22nd launches this big puffy kind of thing. This is what looks to be an Earth-directed stealthy solar storm. This storm could reach Earth around late on the 22nd or 7th. Late on the 26th into the 27th. So we could get a little bit of aurora from that, but it's really hard to tell. I don't know if the models are going to pick this one up. Meanwhile, not to be outdone, region 3102 fires off a big solar storm to the west of Earth. It's not going to hit Earth. And not to be outdone again, region 3110 then launches a big solar storm off to the east. Neither of those are Earth-directed, but they sure made some really good eye candy. On top of that, we have another big flare player. That's region 3105. This region is one to watch as well because we could get some big flares from it and radio blackouts. So it's kind of hard to know where to put your eyes this week, and we're going to keep our eyes on all of them if we've got enough of them. Meanwhile, as we take a look at the Farsighted Sun, now this is stereo A and it's looking at the sun just a tiny bit from the side. You can see region 3102 launching that big solar storm off to the west of Earth, and then beyond it you can see the big coronal hole in the south. And look over here in the east though, in this coronal hole you can look at region 3110 really beginning to emerge very rapidly. And when we see that kind of activity, that means that these regions are very unstable. So this is going to be a really good flare player and obviously a solar storm producer. So we're going to keep our eyes on it. And meanwhile, amateur radio operators and emergency responders and GPS users expect those radio blackouts to be on the menu. Switching to our moon, we are now passing through the new moon phase, with the new moon being on the 25th. And even by the 29th, the moon will still be only about 14% illuminated. So you night sky watchers, if you want to catch those dim objects in the sky and possibly some aurora, now is your perfect chance. Switching to our solar storm conditions and aurora possibilities over the coming week, we are anticipating the fast solar wind from that coronal hole that's rotating in through the Earth strike zone right now. As a matter of fact, we're beginning to experience a little bit of it already. So at high latitudes, NOAA is expecting minor storm conditions with up to about a 50% chance of a major storm over the next day or two. Then things will settle down a little bit. But remember, we also have that stealthy Earth-directed solar storm that's going to hit us somewhere around the 26th, late on the 26th into the 27th, and that could bump us back up and basically extend the storming for a little bit longer. So we could be storming, especially at high latitudes, in through midweek. So this looks like a good chance for you aurora photographers if you're at high latitudes to get some decent shows. Now, mid latitudes, we're only expecting active conditions, but we do have up to about a 30% chance of minor storm, and then things again will settle down with that fast solar wind for just a skosh and then pick back up either late on the 26th or into the 27th because of that stealthy solar storm, and we could get back into storm conditions, but most likely it's going to be pretty mild. We may not even notice it, just a little bit of an enhancement. So those aurora photographers at mid-latitudes, well, you know, you could get a little bit of a show. I'm not sure it's going to be super overwhelming. Don't expect it to be monstrous, but it could give you a little bit if you're a dedicated chaser. Switching to our solar flare and particle radiation storm outlook over the coming week, well, we do have a lot of big flare players on the Earth-facing disk this week, and that means the chance for radio blackouts is staying pretty high. In fact, we're all in the yellow. NOAA's giving us about a 30% chance of M-class flares and even a 5% chance of X-class flares. And this means GPS users need to stay vigilant because GPS reception, especially near dawn or near dusk, could be a bit impacted impacted. Now, luckily, the solar flux is staying high for amateur radio operators and emergency responders, so your dayside radio reception and radio propagation should remain in the good range, despite all the noise on the bands that I'm sure you're getting this week. So just have to deal with that. It's easily going to continue over this week. At least your radio propagation will remain in the good range. But also when we get that solar storm hitting, both you GPS users and you radio operators, just know the night side could be a bit dicey, especially near Aurora. So also now when we take a look at our radiation storm possibilities, we are sitting in the green. Everything is normal right now. So despite the fact that we have big flare players on the Earth-facing disk, it doesn't look like we have any risk for radiation storms, and that's likely going to continue easily through this week. So the space weather this week continues to be interesting, and it's changing very rapidly. Not only do we have some fast solar wind that's hitting Earth right now, and that could bring aurora, especially down to high latitudes over the next day or so, with even some sporadic shows at mid-latitudes. But we also have that Earth-directed stealthy solar storm that could be hitting Earth around late on the 26th into the 27th. I don't know if we're going to see any modeling on this one, so it's just going to kind of have to be an educated guess there. And it might not be a big impact, but it could extend some of the aurora that we've been seeing from the fast solar wind in for an extra day or two before things settle down. So aurora photographers at high latitudes, you definitely should get some good shows. At mid latitudes, well, if you're a dedicated chaser, it might be worth a look. Now, amateur radio operators and emergency responders, well, you know, we've got multiple big flare players on the Earth-facing disk, and that does mean radio blackouts are back on the menu. The nice thing is that radio propagation on Earth's dayside should remain in the good range, even though the bands will likely be noisy with the chances of these radio blackouts, especially because these big flare players are also big solar storm producers. So, you know, there could be a lot more in store, and expect the forecast to be changeable very rapidly. Now, all for you GPS users, well, things aren't looking so great for you right now. Not only do we have big flare players on the Earth-facing disk, and that causes radio blackouts, which makes dawn and dusk really kind of dicey, but the solar flux is also high, and that causes issues for you now down near low latitudes. But then also, once that solar storm hits and the fast solar wind picks up, well, then that's going to make GPS reception a bit glitchy in and around aurora on Earth's night side. So just stay vigilant and make sure you calibrate your magnetometers often if you are a drone pilot. I'm Tanya Scove, the Space Weather Woman. Thank you for watching.
Okay, thanks, Tamitha. She does such a passionate, excellent job at the solar report. I just wish it would time perfectly for the Friday night broadcast as far as looking towards a week in advance. But anyway, it's always fun to listen to her. She's like I say, the passion is quite good. So there it is, and of course her call sign, for those that are interested, her call sign's WX6SWW, Space Weather Woman. How's that? Look it up on QRZ.com. WX6SWW is her call sign. I think the linear that I'm using for 160 is just about had it. It just doesn't like AM. Anyway, that's another story. All right, so now we go quickly to the current space weather report, space from spaceweather.com. And what do we have here? Okay, so the solar wind is currently at 522.6 kilometers a second. It's a real hurricane, and a density of 12.06 protons per cubic centimeter. There are 4 sunspots on the disk of the sun as we speak, and I did get a picture of that, even though it's not really high res. There it is. I don't know why. Usually the image that the spaceweather.com has of the disk of the sun's nice and high resi. You can make out the plasma and the filaments nice and sharp. But today's one's a bit blurry looking and a bit odd shaped as well, a bit egg shaped. But that's the current disk of the sun with 4 sunspots fairly clear to see. So continuing on with the report there, at the moment the sunspot number is 56, and the radio sun, measured at a wavelength of 10.7, is, what did I do that for? Is 137 solar flux units. 137 solar flux units, which is still reasonably high for the scheme of things. Now there is a little sun flare going on here, or a picture of it. Let's see if I can just bring that up quickly too. All right, there it is. Now, what are they saying here? Firstly, minor CME impact. A minor, almost imperceptible CME swept past NOAA's Discover spacecraft on 30th of September at 0430 UT, striking Earth 94 minutes later. No geomagnetic storms are expected as a result of the weak impact. Also, Geomagnetic Storm Watch G2 class. NOAA forecasters say that a G2 class geomagnetic storm is possible on October 1st. In response to a double blow, a solar wind stream is expected to hit Earth's magnetic field. It is following an equatorial hole in the sun's atmosphere. The CME will pass very close to the Earth, potentially grazing our planet. It left the sun on September 28. This is what happened during the last G2 storm, and what we're seeing on the screen now is a large and active sunspot group is about to rotate over the sun's northeastern limb. We can see it coming from the turmoil visible above the horizon. It has already produced an M1 class solar flare on the 30th of September, 04 UT, partially eclipsed by the edge of the sun. The unobstructed flare was probably much stronger. Helioseismologists have been tracking the sunspot group for more than a week. It is altering the way the whole sun vibrates, creating a dark echo in the acoustic maps of the far side of the sun. Soon we will see it with our own eyes, taking precautions, of course. The first dark cores should emerge this weekend. So there's definitely some very interesting things happening this weekend, which could make HF propagation sparkle. All right, now there's a little interesting report here on Europa. I didn't go down the page when I was looking at this, but they've got a report on Europa. The first pictures from Juno's flyby of Europa on September 29 have arrived on Earth, and that is rather spectacular. So I would suggest visiting spaceweather.com to have a look at that. And finally, on the 30th of September 2022, there were 2,298 potentially hazardous asteroids. All right, so that's it. I think we'll conclude with that, and I'll come back to the camera. All right. Okay, this is VK3EKH, ASV Radio, concluding for this Friday, the last day of the month. And don't forget to wind your clocks forward for daylight saving this Sunday. I thank Don, Andrew and Stephen for their emails, and Ian as well, all giving me interesting comments there. I hope Andrew, you're able to see Neptune, but I'm not sure what the chances you're going to be, but I wish you luck on that one. G'day to David, VK3KDM, Mount Burnett Observatory, and Bill, VK3KH2, who's obviously watching as well. So, okay. All right, there's a few articles that I held over, which I'll do next week. So on that note, is there anything else? As we all know, the Artemis rocket has been taken back into its hangar. It's a very huge hangar, there's a name for it. But because of the hurricane beating down over there at the moment, any possible launches of Artemis, of course, have been well and truly postponed. And so it's been brought back into its huge building. I know there's a name for it, but I can't think of it. So we just have to wait a little bit longer for Artemis 1 to take off. Okay, so on that note, this is VK3EKH on behalf of the Astronomical Society of Victoria. Concluding transmissions for tonight. We shall conclude transmissions on 160 metres, our 160 metre service, and would appreciate any reports for our AM stations on 160. Please write to or send email to vk3ekh@gmail.com for reports on 160. So I shall give that linear a rest. So standby stations on 80 metres for a quick callback. This is VK3EKH ASV radio concluding on 1865. Oh, yes, okay. Linear doesn't like running AM for too long. Constant carry, it's not really good for it. Alright, this is VK3EKH taking a quick listen on 3541 kHz for any stations wishing to check in. Okay, so a couple of stations I might have missed because I didn't have my my speaker switched to this radio. I've got VK3HDX, VK5KKT, VK3TJS. There was another station in there that I didn't get. Then VK3KHT and VK3SPX. Who didn't I get? All right, VK3VIN, VK3JR, and VK3KIS. Beautiful. Okay, we'll pick up any other stations in a minute. We'll go straight to Don. VK3HDX, VK3EKH. G'day, Don. Yeah, thanks, Don. I totally agree with you. The I mean, when we were watching the video or the live footage coming through on Tuesday morning, I at first I wasn't quite sure whether it was going for the other asteroid, the larger asteroid, and then of course that started to veer off to the left side of the screen. And all of a sudden, this tiny little object was getting bigger and bigger and bigger in the center. And I thought, well, it must be going for that guy. And it's just amazing that, the physics, astrophysics, the whole science of being able to get a spacecraft to do something like this, it's just outstanding. It all works. It really is outstanding. Anyway, so it will be interesting to see what the science now proves after this and what comes from it. So stay tuned. I shall keep you guys abreast of any updates on that one. Thanks, Dom. VK5KKT. Ian, how are you? VK3EKH. Thanks, Ian. VK5 double KT 2 worlds, VK3 EKH returning, and yeah, the mind boggles, that is for sure. It's very much like something out of Star Wars, I agree, and science fiction. But how many times has what gets depicted in science fiction turned into some sort of reality at some point in time? By golly, I hope the Star Trek universe really happens at some stage in the future. Anyway, but that's just because I'm a Star Trek fan. Anyway, thanks, Ian. And you're just above the noise floor here. You're just creeping through. So I really do crave for a lower noise floor here. Anyway, it doesn't matter. But I heard you. That's the main thing. Thanks, Ian. Jack up at Shepparton, VK3TJS, VK3EKH. Thanks, Jack. VK3TJS, VK3EKH returning. Very good. Excellent stuff. And thanks for giving that little report to Ian there too. I'm sure he appreciated that. Yeah, not a problem at all. Good signal from you. Peaking up to 20 on over just on that last bit there too. Thanks, Jack, for calling in. And it's across to Ian, VK3VIN Kangaroo Flat. This is VK3EKH. I know what you're going to say. Thank you, Ian. VK3VIN, VK3EKH returning. Yes, look, it's. I think one of the interesting comments that I've read mostly about this hitting this experiment in impacting the asteroid to see if we can knock it out of its current orbit is that ultimately and ironically it actually ends up colliding with Earth at some future point as a result of the impact. Of course, that's not likely to happen, but it's just one of those ironic scenarios that due to human folly, we end up causing our own demise by deflecting this asteroid ultimately to hit the Earth. So, of course, it won't happen. No. Anyway, all right. Thanks, Ian. Bill, VK3KHT in Wallen. How are you, VK3EKH? Very hard to hear you. Oh, Bill, that was very hard copy. Sorry to say. I only probably caught the odd word in that. So yeah, I mean you're just up the road, literally. So you should be a better signal, I would have thought. But yeah, very very hard copy, that one. I'm sorry, Bill. There was something you were reporting on at the beginning. I wasn't too sure what that might have been, but yeah, no, very very hard copy. I'm sorry, Bill. I didn't really catch too much of that. So go figure. Anyway, we've got you in the log. It's the main thing. We have next is Stephen, VK3SPX out at Burringup. Have a go, Stephen.
And what I didn't see until your broadcast was the view from the little spacecraft or whatever it is trailing the dart thing, and that really huge explosion or release of energy when this thing hit going several I think it was like 6 miles a second or something they said. So a lot of energy when a refrigerator hits something else at 6 miles a second. You wouldn't want to be near there, would you? I was amused about your comment about maybe they hit it and it sort of hit Earth 20 years later. I reckon they probably thought of that. That would be really embarrassing, wouldn't it? It was the first thing I thought of too, but I think they probably did their sums pretty well to make sure that wasn't going to happen. Anyway, back to you. Thanks, VK3EKH to the VK3SPX.
Yeah, no worries, Stephen. VK3SPX, VK3 EKH returning. Very good. Yeah, no, I think a lot of people thought that, but I think you're perfectly correct. These scientists, quote from Contact the movie. Now, these scientists have had their chance. Sorry, if you haven't seen Contact, I recommend seeing Contact. Anyway, yeah, so I'm sure that the astrophysicists did all the calculations, as you said. I mean, they've got the thing is they've got supercomputers that will run all the possible scenarios and calculations and how it all works. So they can't they can't really go wrong. Yes. Anyway, all right. Thanks, Steve. You're a good signal here too. Hovering in around 20 over 9. So from 1 weak signal to a strong signal. It's interesting how it works. To Frank, VK3JR. And I suspect you'll be coming up on Steve, Mr. SL's broadcast on 160 in a short moment too. So that's if he's around tonight. I don't know. He might not be around. I don't know if you've tuned in, gone to Dave Stewart's Shortwave Australia YouTube site. I think it's all the one thing really. But there is a video that Dave has put up, kind of a combination of recordings from the Coffee Break net, including I think yourself, or there's at least you're mentioned in it somewhere along the way too, which is interesting to listen to. That's on Dave's Mr. ASE's YouTube channel. And I think it's actually titled Shortwave Australia. Anyway, enough of that. Jeez. To you there, Frank. VK3JR, VK3EKH.
Enjoying the radio station, 4835 and 2231. Otherwise, great broadcast. I love Sam as well. More I hear, I love the studios and I just keep really that going on it. If you could read the newspaper, I think I'd enjoy it. Very good broadcast, basically. Yeah, for sure. I like the two words. Ian and Andrew. And they strong enough to understand. And otherwise, that's about it. YJ2, have you been in touch with him at all lately? He hasn't been on these airs quite a long time. I hope he's okay. If you happen to be talking to him, please send him my best wishes.
Thanks, Frank. VK3JR, VK3EKH. I think you were talking about Steve, Mr. YJQ. Yeah, look, he hasn't been up on the ASV net for quite a few weeks. I think he's had a few little things, a few illnesses that have been catching up with him. So he's inclined to hit the sack fairly early, and of course he'll not worry about trying to stay up for the broadcast. But anyway, I know that Steve's pretty much involved with the Great Melbourne Telescope in a big way. And also, of course, helping out with the radio astronomy section. So he's very much divided between things at the moment. But anyway, good on the bloke. And yeah, no worries, Frank. What you were saying? Yeah, look, I lashed out a few weeks ago to buy a broadband receive antenna. I haven't put it up yet. But one of the main reasons for getting this diamond broadband receive antenna was that I should be able to set up a couple of channels in the receiver here, which will be set on Shortwave Australia's frequencies, and be able to monitor them just by turning up the volume. So I've got to do that. Must do that. Anyway, thanks, Frank. Across to Andrew, VK3KIS, VK3EKH. VK3KIS, VK3EKH. Yeah, no worries, Andrew. A little bit hard to copy sometimes. I think there's a bit of distortion on your audio too. It sounds like RF feedback going on, a little bit of RF feedback happening somewhere. So it's contributing to difficulty in copy, but still managed to hear most. And yeah, look, I hope you can get a chance to view the sky. I'm not sure what the visibility is like at the moment with the cloud cover. But yeah, it's Jupiter is the one to look at the moment. In fact, that was going to be a report tonight because Jupiter is coming up to its closest approach to Earth. So it would be really quite spectacular, I think, in telescopes at this point. So I'll run that article next Friday. On Jupiter's proximity. So, and I might even drag out the telescope, the Cassegrain, and see if I can see what I can see with that. Okay, so thanks, Andrew. And I can see that Kim VK5 FUSE was also there tonight. So if you're still listening there, Kim, he's made a comment up there on the chat window. So glad to see that you also were about as normal as usual. All right, I'm going to take one more listen to see if there's anybody else wishing to check in for tonight. This is VK3 Echo Kilo Hotel listening on 3541. G'day Tony, VK3 VAT, VK3 EKH, have the same mate. Oh, yep, you're right. Back. As in, like the Deep Space Network, the radio, the dish antennas up at the Deep Space Network in Canberra. You're referring to that one, are you? Yeah, no worries. Tony, VK3 VAT, VK3 EKH. Excuse me. Yeah, look, I actually, to be honest, I wasn't. I didn't bother to check what Earth station was receiving most of that information. So it stands to reason that our Deep Space Network at Timbanella was probably recording it or receiving it. Of course, there is a website associated with the Deep Space Network that shows you graphic representations of the dishes that are online and what they're currently receiving, and a little bit of technical data. So I should have had that. Oh, I was actually at work at the time that the impact occurred, so there wasn't a whole lot that I could actually do. But anyway, I did send you the text message, though, to let you know that it was about to occur. I would have missed it if it wasn't for the fact that I was on... I had a quick look at Facebook, and some of the web pages there, the astronomical pages were announcing the fact that the dart was about to impact. So I thought, oh my goodness me, that's just in half an hour's time sort of thing, just before our tea break. Lots of work were being done at that moment. Anyway, no worries. Thanks, Tony, for calling in. If there's no other stations, we shall conclude our transmissions for tonight. I'll take one more listen. It seems the closest the stations to here, the weaker they are. You're not really strong. Both of you guys aren't really strong. You should be bending my needle. You really should be. VK3 VRS, VK3 CSJ. Go ahead, Richard. No worries, Richard. Thanks very much for the report. And I was listening on the 23 centimetre frequency, but everything must have gone okay. So there was no feedback coming through. So everything was quite good. On that note, we have there's an email from Ian. Have I read that yet? It's he says thank you for the broadcast, and yep, no worries, Ian. And there's also another one from, no, that's just a bit of spam email. I shouldn't have even opened it up. And I'm so thankful that I am not with Optus. Anyway, all right, everybody, take care, look after yourselves, have a great weekend. Don't forget daylight saving stuff happens this Sunday, and we'll be back next Friday to do it all again. And I can see VK3SL has started his transmission on 1865 AM, and also a quick promotion to VK3 AML's Saturday night video live transmission he does from about 9:30 for about 2 or 3 hours. Chris, VK3AML, has his own production show program that he runs for educational purposes, which he also runs on 2 Meters FM. And but just search VK3AML on YouTube, and from 9:30 onwards every Saturday night. And he has some of the most interesting discussions and interviews and things that he talks about. So most entertaining. All right, this is VK3 EKH concluding transmissions tonight on 3541 and on YouTube and elsewhere. So thanks for watching, and we'll see you all next week. Take care, look after yourselves. VK3 EKH clear on 80 meters. And thanks to everybody who was on the Discord. Well, yes, actually, I was just about to conclude my my YouTube channel, so I've got to do a little bit of blurb there first, and then I can come back here if you like. VK3 VAT, VK3 CSJ. All right, I am going to turn that volume down. All right, everybody watching YouTube, where's my camera? Up there. Thanks for watching. The 19, 20 odd people that seem to always watch the channel. So that's all right by me. I'm so tired. Like I say, have a nice, safe weekend. Thanks for watching. This is also going out over Melbourne TV repeater. I don't think the BATC feed was working either. So doesn't matter. But anyway, thanks for watching, and hopefully we'll have some more interesting video stuff to run next week as well. So this is ASV Radio on behalf of the Astronomical Society of Victoria, concluding the YouTube feed, and thanks for watching, and don't even bother about leaving a comment if you don't want to. Everybody says that. Leave a comment, subscribe, but who cares? All right. Let me fade away.